Hey guys, today I'm doing a power jack repair on an Acer Nitro 5 laptop. This is another one that had the classic symptoms of just being able to plug in the power cord and you can wiggle it in just the right way to make it work. That battery light just kind of comes off and on and just flickers back and forth from AC to battery power. And with this one, you need to remove the bottom, all the screws for the bottom cover. Once these screws are removed, you can take a pry tool. I prefer to use a thin guitar pick, and you can pry around the edges of the bottom cover and then it'll come off. This one comes off pretty easily. Just taking that pick and dragging it around will be enough to get that thing to pop up. Take the other hand to kind of apply some pressure upwards and that thing will come off relatively easily. Now the first thing I'm going to do here is disconnect the battery. I always like to do this first just in case the computer's in standby or something. You want to make sure there's no power going to it. And here I'm just taking a small flathead and prying up on that CMOS battery to get it unstuck from the chassis. And there I'm detaching the speaker, and here I'm going to detach some of the backlight cables and keyboard and touchpad, etc. And with those little connections, you just flip them up with the flathead or with your fingernail. And then those little connections, they don't come off, they just flip up to open and flip back down to lock, so be careful with those. I see those broken all the time. And that one I just disconnected was for the I/O board. And there I'm just removing a fan cable and the LCD cable. And the LCD cable is taped over the heatsink, and then when you remove the heatsink, you'll run that LCD cable through the heatsink. So here I'm detaching the Wi-Fi leads. And those are just like the video cable where they have a piece of tape there. You remove that tape and they'll go through the heatsink. And here I'm detaching the fan. And here's the other fan. I just try to apply pressure one side with the flathead, one side with my finger. You want to be careful with these. You don't want to pull up on the cable itself. You want to make sure you're trying to remove it like via the connector, not pulling on the cables. If you pull on the cables, you can just rip them out of the little input there. And sometimes these are really tough, so just be careful with them. Here I'm getting two flatheads to try to go even on each side. I wasn't able to get my finger in there properly. And so here I'm disconnecting, or removing rather, the fan screws. And after I've done the fan screws, I'm going to remove or unscrew the heatsink screws. I don't think these come off, they just loosen. So sometimes these kind of take a little bit of strength to get them to come off, but this one came off really easily. It's like that thermal paste is stuck to the GPU and the heatsink, so sometimes it's kind of hard to come off, but you just pry it up carefully and then take that LCD cable and Wi-Fi leads out through the hole there. so now I'm going to remove some motherboard screws. There's a little screw under that I/O cable. And then a few up top here. And now I'm going to try to remove the motherboard. Just be careful with this. You don't want to snag something, or if you still have something plugged in that you forgot to remove, you want to be really careful when removing the motherboard. It just kind of lifts out of there like that. And so here we go. Now we have access to the power jack to replace it. So now it's time to get soldering and desoldering. And this is a pretty beefy DC jack. This one really does not want to come out easily. It takes a lot of work. This is a longer video, and I've sped the video up in some parts here with the desoldering and the removal of the jack just because it takes so long for me to get it going. So here I'm going to apply the flux. And this is part of my desoldering process. I like to add some flux, add some solder, get those holes heated up and get the solder flowing in between those through holes, and then try to remove it. And in this case, it's going to need a hot air station to remove it. It's just that solder does not want to come out. So, but at the same time, I want to get as much of it out with the iron as possible. And now that I've added some solder to each one of the holes, I'm going to take my desoldering braid and get this thing, as much of it desoldered as possible before we go to the hot air station. And I like to use a flat chisel tip. I feel like that's the best way to kind of to get that through hole heated up properly. If you use like a pointy tip on these soldering irons, it just doesn't really do much. You're really not getting that through hole heated up. So the chisel tip's kind of like the through hole. As you can see, it's kind of rectangular, and the chisel tip is kind of rectangular as well. So when you put that chisel tip on there, it heats the hole up the best way I found to do it. And it's almost like a square or rectangle. I try to you have four sides to a square or rectangle, so I try to desolder it from each one of those angles there. And this is just a long, tedious process. You're going to have to do sometimes I do the adding of the solder and the desoldering, multiple times. Sometimes with the first pass doesn't work, so I have to add some more solder, add some more flux again. I know it sounds counterintuitive to be adding solder to something you want to remove, but this really just helps get that through hole heated up and get that solder flowing. And if you were to not use the flux, if you're not using the solder, it's just almost impossible to get that to come out. It's hard enough as it is. And if this is a service that a kind of repair that you're not comfortable with, we provide this as a service for $99, parts and labor at pcrepairhelp.net. All the information's in the description. And I usually do a flat rate of $69, but the cheapest I can buy these jacks for right now at the time of this video is about $30. So this one's a little bit more than my standard $69. This one runs $99. Hopefully the price of those jacks will come down in the future, but And a couple other things, I'm using a Hako FX888D soldering iron. It's not too expensive, but not cheap either. And I typically solder about 750 degrees Fahrenheit. It's pretty standard stuff. And I'm just using some regular 6040 solder, and I think the solder flux is from MG Chemicals. I'll put a link as well. It's 8341 no clean flux paste. Really good stuff. And here I'm just taking my 99% alcohol. I'm going to clean it up and get everything prepped for the hot air. Now that I've got as much solder out of there as possible, it's time to go to the hot air station to finish this thing off, to get the removal done. And here I'm just taking my thermal tape and putting it over these sensitive components that surround the jack. You want to make sure you have this thermal tape on there. You don't want that hot air station to heat up and blow off something small like those resistors that are surface mount. So I just kind of make a little wall around the jack and try to cover everything up. And now we're on to the hot air. This is also sped up as well as the previous part. Just it's kind of long and boring, but this is just a really thick motherboard, and it just takes much longer for this thing. There's some motherboards I work on from Acer, like the Aspire 5 and the Aspire 3, for example, that I only need to put the hot air on there for about a minute or so. But something with a really thick motherboard, like there's these Acer Nitro 5s and the Helios 300, they take quite a bit longer time, more like 10-15 minutes of hot air. And you're not, if you don't have it, I set my hot air roughly around 400 degrees. If you have it set to something reasonable like that, you don't worry about burning it or anything. But you'll know, as you'll see in the video here, that solder will start to melt. You'll see like a visual change in those through holes, just kind of starting to flow a little bit. And then I'll take my tweezers or pliers or whatever, and I'll kind of start giving it a little bit of movement, a little bit of a nudge to try to get it out. But you just have to stay persistent and just make sure you keep that hot air over there like I'm doing. So I got the tweezers here. I'm just kind of checking, how much that heat is starting to affect it, if it's making it loose or not. I'm just trying to go over, evenly distribute the hot air over each one of these holes. And it just takes time. Just checking again here, and this thing is just still in there really good. And I can't tell you how thick this motherboard is. I mean, it's literally like double the thickness of your typical motherboard. These gaming laptops have a lot going on with their GPU and CPU and all the components on there, so just a more lengthy one than normal. And you can fast forward this stuff. This isn't really important. I just kind of like to show the actual full length of what I'm doing and how long it's really going to take you and what you can expect. Sometimes it's hard when you see a YouTube video chopped up into pieces and you think, okay, is this supposed to be like this? What am I doing wrong? But I like to put the full video out there so you can see exactly what I'm doing. Just checking it again. Nothing much. Now I think it's finally starting to loosen up a little bit here. You'll see each one of those through points start to get shiny, kind of like if you were soldering it or something. And obviously when I'm wiggling that jack, it'll move a little bit. And there I'm getting some movement, but it still just needs some more constant heat on it. But it's starting to come finally. It's finally starting to get somewhere here. I can see that solder flowing in there. I'm just wiggling it around to kind of make it, help it come out. And she's almost there. And there it comes. Finally comes out. And so now, the same thing with the last part. I'm going to just speed it up a little bit. Doing the same thing as before. Going to add some flux, going to add some solder. Try to get these holes flowing. And as you can see, the solder does come out okay in this, but you have to make sure you get every single little piece of solder out. And what you'll see here shortly in the video is I can't get every single piece of solder out, and when you try to put in the new jack, it doesn't want to go. So I have to have a couple tips and tricks here that I'll use to try to get that remaining solder out of there to get the jack in there properly. But for now, just want to add a bunch of flux. And keep trying to remove as much of that solder as possible. This solder is just really stubborn. I don't know if it has some like a high silver content or what's going on, but it just does not want to heat up and come out of there. So this can be a really big pain. And for someone who's been doing this for almost 20 years, when ones like this give me trouble, it can be very difficult if you're just beginning or trying to do this yourself. So just be wary that it's not just you. It's even a little bit difficult for me. So here I'm just having to add some solder. Sometimes with some of that solder that doesn't want to come out, if you add some of that solder, it kind of sucks it up into a one pool that will maybe actually come out. You get some of that flux in there, and that really helps it come off into the braid or pump it, whatever you're using. But adding solder can be a really good trick. And then here what I'm doing is I'm adding some solder, I'm getting that through hole really hot, and then I'm taking that small flathead that fits inside the through hole there and just kind of punching that solder through. Because it just will not come off into the braid. So taking what you'll see here in the video is me right there taking that small flathead and trying to push that solder through to the other side, and then you can flip the motherboard around and try to desolder it that way, and you kind of have to flip the motherboard back and forth and keep doing that. And for the smaller, more circular holes, I take the sharp end of my tweezers and kind of poke or punch that solder through the circular through holes as well, or even use it for the rectangular and kind of work my way down. But that's kind of one of those advanced techniques that you don't really think about. Something I just did over the years of just trying to play with this thing, trying to get it to come out properly. And you need to make sure you have the correct size flathead. But as you can see there, it works pretty well just to kind of punch that solder through. And you want to do that obviously when it's really hot. Yeah, just after you take the iron off, you want to go directly to that with that flathead and try to poke it through a little bit. And then hopefully it's a little bit easier to desolder on the other side. But as you can see there, it's kind of working. It's getting some of that solder out. But I add flux and I use the braid, and as you can see, it just does not want to come up. So really punching it out is the only way I've found to get it out properly. But when you do this, you want to be extremely careful. You can damage the motherboard doing something like that if you're not careful. If you try to, sometimes not really on this motherboard, but there's other motherboards where it'll be kind of have a pointy spot where the jack is, like a peninsula, and you won't have the strong, motherboard on each side, and you can really damage something. This is a pretty solid, thick board. It'd be kind of hard to do that, but you just want to be careful when you're doing your computer if it's not a Nitro 5 designed like this one. And so now I flip the motherboard back over, and I'm going to try to desolder some of that solder that I punched through from the other side. And you can pretty much do the same technique, you know, kind of do that we did on the flip side of the board. We're going to do that as well on this side. Try to remove as much of it, punch it back through, remove as much of it, and punch it back through and flip it. I know this is long and tedious, but this is kind of the nitty-gritty stuff that sometimes you don't see in a YouTube video when someone edits it and cuts the stuff, and you don't see that that hard stuff that people go through to try to get these done. You only see the easy parts, you know, chopped up into pieces. So I know it's a long video, but I try to show everything so you know exactly what you're up against. Because it's definitely not as easy as it looks. So now I have the board flipped back over again after doing it on the other side. I'm going to try to remove some more there. I tried to put the jack in, but it's not even close. There are some motherboards where if you don't have all the solder out, you can try to put that jack in, and you can kind of, you know, punch the solder through with the actual pins of the jack. But you know, you have to be careful doing that too. You can bend the pins on the jack and ruin your brand new jack that you just have. And not many people have multiples laying around, so you know, if you break that first one, well, now you got to order a second one. So just be careful with that too. And then I'm just taking that flathead, trying to get as much of that solder pushed through there as possible. This is definitely a tougher model. This is the same motherboard as the Acer Predator Helios 300, and these are just not easy ones to work on. There's some ones like the Acer, like I was talking about earlier, the Acer Aspire 5 and Aspire 3, where they use this teeny little jack and comes off really easy, goes in really easy, and you know, makes power jack repair look really simple. But you know, this is definitely kind of like a difficulty. I'd say, you know, like an 8 or 9 out of 10 if you were to rate it like that. This is not a simple one. So here I'm going to put the jack in, and it doesn't fit in properly all the way, but sometimes it just needs a little bit of coaxing. So I'm taking that flathead and I'm poking some of those pins and trying to poke them through the motherboard. You know, if it's like anything, if it goes pretty easy and it pokes through easily and it's something that's working well, you can do that, but you don't want to force anything. You don't want to push anything through too hard. You know, like I said earlier, you might bust the jack, or you know, you could do something wrong to the motherboard. So I'm just trying to be careful with my flathead here, but sometimes this works really well where you're like right on the verge of it, and you can't get any more solder out of that through hole. So you're just taking that flathead and pushing those pins through to the other side, and that can be an effective technique too. But if you're trying to put it in and it's just not going, then you kind of have to go back to the drawing board and do some more of the desoldering work. And you can kind of identify what points aren't working. Sometimes a couple of the pins will go through and some won't. So just got to keep trying, got to keep at it. Don't get frustrated. Just be persistent. And those two back, the largest through holes there, largest pins going through those big through holes on the two back, those are the really difficult ones. You know, but the legs on that jack are pretty sturdy, so you can push them through with the top on the flathead like I was doing. But if they're really not going, then you simply just don't have enough solder removed, and you kind of have to go back and try to remove some more. So as you can see with this 3 times sped up video, I mean, it just takes a lot of coaxing, a lot of play with a model like this one, a design like this one. And sometimes it still just will not go. And I think what I'm doing right here, I'm sorry I cut put the jack out of the video, but I think one of the pins got bent, so I had to bend it back, trying to push it in here, which is no big deal. These are really strong pins on this jack. If they get pushed up a little bit, you can just take them right back and bend them. Alright, so I finally have this jack in here, and like every time, whether I'm desoldering or adding new solder, removing or putting the new one in, just add some flux. That'll make that solder go through the through hole really nicely, go through each side. And I'm just going to add some solder to each one of these through holes, make it look nice, make sure that that solder is flowing all the way through. And sometimes the solder, I even add extra flux. It's like that after adding that initial solder, it just does not want to go through the through hole very well. So adding some flux can help make that solder dip down into the hole better and just make for a better connection. So as you can see here, I'm going over each hole multiple times, making sure that thing is good to go. Sometimes it needs a little bit more solder, sometimes it needs a little bit more flux. Sometimes it just needs a little bit another pass of the iron tip. And here I'm going to clean it up again with some 99% alcohol. And we are all set to go here. New jack is installed, ready to put back together. Thanks so much for watching, guys. If you have any questions, just leave a comment below.